Class is now starting. All attendees are in listen-only mode.
Hello. Hello and welcome to today's SFP's webinar on fire facades, recent developments in Europe. I am José Luis Fernández, SFP's European Director, and I will be moderating today's webinar. Before we get started, I am going to go over some information in regards to the webinar logistics. First, all participants will receive a certificate of attendance for 1 PDH. To receive a certificate, you must stay online for the entire webinar. Certificates will be sent out via email in about 1 week. Also, we do not provide copies of the speakers' PowerPoint presentations. However, we will be posting a video of this presentation on the SFP's YouTube channel and website in the next week. Additionally, you can ask our speaker questions by writing it in the webinar dashboard. You may ask a question at any time. However, we will not be taking any questions until the end of the webinar. Well, I'm very pleased to introduce today's speaker, Lars Bostrom. Hi, Lars.
Hi.
Well, Lars Bostrom has a PhD in material science from Lund Technical University. He has been employed by RISE, previously the Technical Research Institute of Sweden, since 1991. He managed the Department of Fire Resistance for over 20 years and has led numerous national as well as international research projects. Probably he will tell us more about his own career, but now I'd like to welcome Lars. This is yours. Go ahead.
Thank you very much, Jose, and welcome to this webinar. It's afternoon and 4 o'clock here in Sweden. Very nice weather outside. Yes, I got some introduction, but I would like to say a few more words about my background. I have mainly been working at the Research Institute since I made my PhD. So I have never been out in the building industry, never been working as a consultant. I don't know very much about building engineering, although I have quite a lot of expertise in testing and assessments in the field of fire. So let's start this webinar about the facades and fire. And I think we all know that facades can burn and that they do burn. We have seen many different facade fires. Many times it goes well, and in sometimes it goes very badly, as in the case with the Grenfell Tower fire 2 years ago. Facade fires, they are very difficult to understand, I would say. So I think we have to go into a lot of details. And just to start, what is a facade? If we look in literature, or if we look on the web, or if we look in building regulations, we can see there are a lot of different definitions of what is a facade, really. And we can see in some cases it's just the outer skin of a building, or in some cases it could be the complete exterior wall, and of course it can be everything in between here. So the definition of facade, it is not clear, really, what is a facade. And furthermore, if we start to look on a facade, it is quite often very complex. It is built up of different materials, and you can have different layers of materials, can be very complex geometries, and a lot of different detailing, and you can have penetrations, you have windows. So it is a very complex structure. So it's not so easy to understand as we often do when we look on the test methods and so on. Then we build a wall and we put one material on this wall and then we test it and we think that should be a model of what is in the real life. But it is not so simple. And furthermore, we have different types of buildings. Typical Swedish cottage must of course have different rules compared to the high-rise building. Or if we look on buildings with special purpose like hospitals or living for elderly, there you have certain requirements. So the requirements on the facades must be quite different depending on what type of building you're talking about. And then we come to the fire scenarios. They can be quite different as well. And we have to define what kind of fire scenarios are we going to protect against. It could be fire from a neighboring building where you have an influence of radiation. And here we can see that we have regulations and requirements, for instance, on the distance between buildings. We also have the case with external fires. It could be a car or a garbage bin or something that are placed below a building that catch fire. And then, of course, we have the internal flashover fire from a fire cell that protrudes out from a window that breaks, which is the case that is most usually investigated through fire testing. And then if we start to talk about the fire spread, it can be on the outside of the facade, if it protrudes out of a window, or we can get the fire spread within the facade system, or it could also be between the facade system and the floor slab. So there are different scenarios that must be covered as well. So how do we assess then the facade systems? There are many different ways here, and we can see that in the regulation also. We have, of course, the tool fire safety engineering, which is a very good tool. And it is a possible way for some cases. I am not sure that it can be used for all cases. We can see in some countries we have very much prescriptive rules. They are very good, but the drawback with the prescriptive rules is that they prevent new innovations. We have the type approvals, where we have, for example, the CE marking, but we have also other national type approvals. And that could also be a system that works to assess facades. And then, of course, we sometimes use specific testing for a specific project, which in many cases is a very costly solution. And it also requires very good knowledge of the test lab, specific if it is a complex facade system that needs to be tested. So there are many different ways that the facades can be assessed. Now I would like to say some words also about the testing and the assessment methods that we're using today. We are talking about reaction to fire, we're talking about fire resistance, and we are talking about fire safety engineering. And we can see that in many regulations, at least in Europe, they are often based on the reaction to fire. And when we talk about reaction to fire, it is mainly material characteristic that we are looking at. But we can see when we're talking about facade fires, it is quite often a fire resistance problem, really, because we do not want the fire to spread to another fire cell. And we also know that we have to rely on fire safety engineering because we can't test everything. And we also know that we are using other safety measures as well, and not only a test report or a test result, but we can use other measures, for example, sprinklers or other ways to get a fire safe situation. So if we look on, go in a little bit more on the details, if we look on the reaction to fire tests, which is, I can say it is used in all member states in Europe when we're talking about facades. In all member states, we have requirements on the reaction to fire for facades. And this can give a good information for some characteristics, and it is for specific materials, and especially then if we're talking about non-combustible materials. But how reliable are the results if we are coming into the field of combustible materials? Can we really rely on the results from a reaction to fire report here? I'm not sure of that when we talk about facade fires, because it is a completely different fire scenario that we have in a facade fire compared if you have a small fire in a room that you want to prevent from become a large fire. And also I have questions when it comes to composites and sandwich materials, if the reaction to fire test give the correct answers, if the materials are supposed to be used on facades. But I think the reaction to fire can be a complement in the assessment. And for sure, it is good if we're talking about non-combustible materials. If they then move on to fire resistance tests, they mainly look on the compartmentation, and that is that the fire shall not spread from one fire cell to another fire cell. And that is, of course, a case when we're talking about facade fires, that we do not want the fire to spread from one fire cell to another fire cell. But it is not really the scenario that we look on in the fire resistance test. We can evaluate, for example, penetrations, but we can only see in the fire resistance test if the fire spreads from the fire room and out to the other room. We cannot see if the fire will spread within the tested element. And we are testing some facade systems in fire resistance test, for example, curtain walling. But here we're only looking when if the fire goes from the furnace, you can say, and out to the open, but not what happens within the tested system. But of course, fire resistance tests can also be a complement in the assessment of facades. And if we look on fire safety engineering then, here we have the possibility to consider alternate safety measures, for example, sprinklers. And we have also the possibility to evaluate more details, which can be difficult in the testing. For example, detailing around windows, perhaps certain penetrations, smaller details and so on. But I think it is difficult to rely only on fire safety engineering when we're looking on facades, because it is, if not impossible, but very difficult to calculate on fire spread. But I think fire safety engineering is a very good tool to use in combination with the testing in the assessment of facades. So that was a little background, and now I would like to go into the testing world. And this picture shows a little bit what it looks like in Europe. We have a lot of different test methods for facades. And that makes the life complicated for industry, because they have to test in every country, and it is the different method. Each country have their own method, so there is a lot of testing to be done. And the facade test methods, how much do they show really? Yeah, they show if the tested facade system have a potential to be safe. And of course, it depends on what risks you're looking at. We also have to see that the tests are always made under perfect and controlled conditions, and it is a standard fire scenario that we are using. So it is a simplified model of reality. And we know also that in these facade test methods, it's very difficult to evaluate detailing, especially smaller details. Perhaps we can see some bigger things, like if you have a window opening, will that affect the fire spread in any way? We also have difficulties to assess more complex geometries of facade systems. So there are a number of things that we cannot really assess through testing. And we can also see that the requirements are quite different also. What are we going to look at? What is important to assess? Is it the fire spread upwards or horizontally on the facade surface in the facade system? Are we going to look on falling parts and burning debris? Burning debris can spread the fire downwards, and falling parts can make it difficult for the fire brigade and so to make their work. We have the junction between facade and floor. Is that supposed to be investigated through a facade test, or can we rely on fire resistant testing there? I'm not sure. We have the problem with the smoldering fires. Today it is mainly Germany that are looking on smoldering fires, but I'm sure that the problem is valid all over the world. And how do we assess that we have really put out the fire on the facade system? Smoke is an important issue. We know that smoke is the main killer during fires. And how can we measure smoke from a facade test? I don't know. It is not done today. I know that there are regulators that would like to have some regulations on the smoke also for facade fires, but that is quite a difficult task, I would say. And then we have also detailing in the facades. In many facade tests that are done, you're only testing a smooth surface of the outer skin of the facade. But we know that most facades have detailing, such as windows or penetrations and so on, which can, of course, impact on the behavior of the facade system. So there are a lot of different requirements that we have and must consider. So the situation in Europe, we have a harmonization in Europe, and the main objective with this harmonization, where we have the building regulation, that is to make trade easier between the member states. And we have the CE marking, And I would say the CE marking, it's a trading mark. It's not a quality mark. It gives you the license to trade your product between the member states. And we have done the building products regulation that sets up the system for the CE marking, and that is mandatory in Europe. Although we have to remember also that the building regulations, that is something that is a task for each member state by their own. So each member state, they put up their own building regulation, but they have to accept CE marked products. So now the European Commission, they want to go for a harmonized product standard also for facades. And to get the harmonized product standard for facades, we have to have some standard procedure on how to assess the facades. So 2.5 years ago, a project was launched. It was financed by the European Commission, and that was to perform a study on the high performance of facades and to propose test methods and the classification system. We were a group that were supposed to do this work, and what we had to do was to make an inventory then of all the national building regulations in the member states, because this method and the classification system, it should fit all the regulations that are used currently in the member states. It was also decided from the Commission that we should work with the two test methods used in Germany and in the UK. That is the DIN 4102-20, which is the German test method, and the British standard 8414. Those two methods should be the basis for the proposed new harmonized test method. And we should also show how a classification system could look like, and finally to define what needs to be done after this project has been carried out. So we was a group consortium with representatives from RISE here in Sweden, from BAM in Germany, from Facades in France, BRE in UK, and EMI in Hungary, who was the project group. And we knew from the beginning that this is not something that we can solve ourselves, so we had subcontractors from most of the member states in Europe in order to get information from all member states. And if we go into the results, we could see then that all the member states have regulations regarding the fire performance of facades. So all member states have some sort of regulation here. They are mainly based then on the existing European system on the reaction to fire and fire resistance. So reaction to fire, we can say that all member states have some regulation for facades on reaction to fire, and some have also something on fire resistance. In 14 of the member states, they have additional requirements that are not covered by the European system for fire resistance and reaction to fire. So 4 member states, they are using some additional tests that must be done. And some countries, they specify a specific test method that must be used. And some countries, they make it possible to have some performance-based testing as well, where they do not exactly describe what test method to be used. It is, they're a little bit more free there. And we could also identify 12 different test methods that are presently used in Europe. A lot of different test methods. So here is a list of the test methods used, and they are all different, but they are to some extent very similar, all of them. So we can say that the size are different, but it is mainly a surface where you which you expose to a fire, and you look on the fire spread on the facade. But what we are looking on is it's a little bit different. They target different aspects on what to assess during the tests. So flame spread is of course one important target that most of the methods are looking on the flame spread, and mainly vertical flame spread, but in some countries they are also looking on horizontal flame spread, and it is all both on the surface and within the facade system. In some methods we're looking on fire spread from one room to another room, where they build up more like a house. You have the method used in France, for example. You have a method used in Hungary, where they have rooms where they put the fire in a room, and then they look on the room one floor above, that the fire should not spread to that room. In France, you also look on the junction between the facade system and the floor. In some countries, it is also mandatory to have some kind of windows or openings, fictitious windows, we can say, that must be included in the test to see the detailing around the window openings. And you also have requirements on smoldering in Germany. Falling parts and burning debris is looked on in some countries. In most tests, we're looking on a fire from inside. That is a fire that a fully developed fire in a room that protrudes through a window. But we also have methods where they look on the external fire. And Germany have a new test method for that, where it is a specific test to look on exterior fires. And then in some cases, you should also look on if there is some damage to the system after the test. So if we look on the parameters to be assessed, we can see that vertical flame spread, it is assessed in all countries that have some requirement that a large fire test should be done. The horizontal flame spread is used in several countries, but not in every country. And the flame spread within the facade, it is in all countries except for Hungary. And the junction between floor and facade, there are 3 countries that are looking on that, and that is Hungary, Sweden, and France. In some countries, they have some heat requirements also, and they're not only looking at a flame spread to a certain level, but they have some kind of heat flux measurements that should be done, for example, in window openings, and that is used in some countries. And finally, some countries have regulations also on detailing. Smoldering, it is only Germany. Falling parts, there you have it in several countries. And smoke is mentioned in the regulations in both Sweden and Germany, but there are no requirements really on it. It just says that the smoke production should be minimized and so on. But it should be observed, but we cannot assess it. So this was a starting point on how to develop a harmonized method, and we could see that there are many things that we have to consider, and it was also obvious from the beginning really that the two methods that they proposed to start with, the German method and the British method, some things were lacking in them, so we couldn't complete the map with all the details that we wanted to or needed to have assessments for. So in our work, we proposed two different methods. One is the proposed methods, which was ordered by the European Commission, and that was to keep the British and the German standard as they are, but we could see that we had to do some minor adjustments on these methods anyway, otherwise we couldn't fulfill the requirements that they have in some countries. So we concentrated our work then on trying to develop an alternative method to combine the British and the German method to one method instead. And this was a proposal made then by the consortium. So if we look on the proposed method, and that was to keep the British and the German method, then we would end up with two different test methods. One test method where we use what we call a medium fire exposure. It's a smaller fire. It's a small wood creep. If I remember correctly, 40 kilos of wood or 20 kilos of wood. And then one large fire exposure test, which is the British, where you have a large wood creep, 400 kilos of wood. So it's two quite different tests. And we call them then medium fire exposure and large fire exposure. Both of these methods, they lack in the measurement and evaluation of falling parts, which needs to be added then, because that is a requirement and that is currently used in several member states. And if the falling parts and the burning debris is to be evaluated, then we may need to change the geometry of the test rig and lift them up so we do not get the, for example, for burning debris, that any debris that fall down on the floor should not be ignited by the fire source. So there needs to be some modifications to the geometry of the test rig if we're going to evaluate the falling parts and the burning debris. We can also see that detailing around window openings and other openings, that is something that is required in several countries. This can be added to the British method. And we also could see from the inventory that we made that in the countries that are have the requirements on detailing around the openings, those countries also requires that it should be a large fire exposure. So that means if we can add that to the British method, it would be a possible way forward. Another important issue is the requirements on environmental conditions when performing the tests. Today, a lot of tests are carried out outdoors, out in the open, and we know that the test is quite sensitive to wind and temperature and so on. So the climate environmental conditions are quite important, and if we are going to have a harmonized method, then we have to be certain that we get approximately the same result independent of which laboratory that carries out the test. So we believe that there will be much stricter requirements on the environmental conditions than what is the case right now in the British and the German methods. But this is still an open question and needs to be looked more on in the next phase of this project. We could also see that the requirements on the fuel specification and ventilation conditions in the test methods, they are quite wide, the tolerances on the fuel and so on. And in order to get good enough repeatability and reproducibility, we believe that the specifications on fuel and ventilation, they must be more precisely described, and more strict the tolerances has to be used. So we think that even if we say that we're going to use the old German and British methods as closely as they are today, there will be several changes to them. If we then go and look on the alternative method, the one that is proposed then by the consortium of this project, that is to combine the two methods, the German and the British method, to one test setup. We can see that the geometry of the test setup is approximately the same. The big difference between the two methods is the size of the combustion chamber. So if we are smart and use our engineering skills, then I think we can easily have one test rig where we can perform both tests. So then I have one medium size fire test and one large size fire test in one test setup. We can also see that the position of the measurements that are done are different in the two methods, but I think with some smart thinking we can use the same position for the measurements also, and we can surely get a way to assess also detailing around the openings, and by uplifting the whole rig we can assess the fire spread downwards through burning parts and falling off. And then this alternative method, it will also give a much simpler classification system. It will be something that is new for everybody. That's the drawback that we can't rely on historical data. Although I think that also with by using the proposed method that we use, the Dean and the British method as they are, anyway we have to do changes to them, so the use of historical data will be limited in any way. So if we move forwards then and look on the classification system that we propose then, and this is only for the alternative method, that will be quite simple. We end up with 4 classes where the highest class cover all the other classes. So that is the large exposure when it fulfills flame spread and also fulfill the criteria on falling parts and burning debris. So this would be quite a simple solution for a harmonized test method. Then the question is this enough with classes? Do we need more classes? Is it enough to have only these 4 classes? I'm not sure. I will come back to that later. So we have made the proposal in this project, at least on 2 different methods that could be worked with in the future. And I know that the European Commission has said that they need to have another work done after this, after what we have done so far, and they will come with an invitation to tender. It was supposed to get out before the summer, but it has been delayed, and I don't know when it will come. We do not know at this stage which alternative they want to work on in the future, if it is to keep the British and the German methods as they are, or if they want to go with the alternative method. We know that they want to have this solved very quickly, so it's supposed to be a 2-year project to finalize the test and classification methods. And the focus on this work is mainly then on getting something so we can see E-mark facade systems. It is not a test method that gives any value for fire safety engineering and so on. And we also know that a big question still is to define the field of application, because that is very important. If you do not have it, you will get an approval for the system that you have tested and nothing more. And I'm sure that the industry would like to have the possibility to make some changes, changing some detailing, and or setting up a test series with a few tests that can cover a much wider spectrum of facade systems. So the field of application is a very important part, which has not started yet, we can say. So I would like to end with some personal reflections also on facade and facade fires. And I would say that the fire safety depends on several factors. It is, of course, the robustness of the building, how robust we build it. If we choose unsafe solutions, then of course there can be problems. So the robustness of the building is, of course, very important. And to use appropriate materials and components, it's not sure that even though material perhaps have passed the test, that it is appropriate to use as a facade material. I have seen many cases where they are, okay, it's okay according to regulation to do it, but it is not a good solution. I think the quality control is a very important factor as well, to have a good quality control during the whole building process. And of course, the maintenance and the use of the building, because things will happen during time, and you have to keep the facade system up to date. And then we have to remember that I'm talking a lot of testing today, and a test is just a simplified, very simplified model of reality. So to rely on the test only, that can be quite dangerous. And we know that facades are very complex, and it is not possible to get all the answers from a test. So we have to have engineers and architects, and as well as the labor at the building site. They have a big responsibility that everything is done in a correct way, and that we're using appropriate materials and solutions. So I think that a mix of available data from tests, from fire safety engineering and quality control, and the maintenance, that is very important to get a mix of all this in order to get safe facades in the future. And with that, I would like to Thank you for your attention. And I welcome any questions.
All right. Thanks a lot, Lars. Yes, I think we do have some time to take questions. So, okay, let's get started. I can tell you there are a few questions there. So this demonstrates that your presentation was very attractive for the people. So let's go for the first one. The first one is related to the sprinklers. It says whether you think that the sprinklers could limit the potential for an interior fire ignited an exterior facade, or limiting an exterior fire from entering the building.
No, I think we have to remember this can be quite different. The building regulations, what they are based on. I can talk about Sweden, for example. In Sweden, it is that we want to buy time. It's the time until it gets a big fire. So through the sprinklers, we can buy some extra time for the fire brigade and so on to do their work. So there you can get some extra time. And in Sweden, for example, we have in the building regulation that if you install sprinklers in some kinds of buildings, then you can take down the requirements on the facade system. If you do not have a sprinkler, then you have higher requirements on the facade.
Mm-hmm. All right. Here there's a question related to the test. It says, which aspects of the falling parts are observed or assessed in the tests?
Yeah, for falling parts, it is mainly the risk for people that are coming below the facade. So it is for people that are escaping from the fire, and also for the fire brigade. That the fire brigade, if they are going to use ladders and so on to get up on the facade, that they can do their work without any risks.
Right.
And we can see that the regulations are a little bit different here from country to country. In some countries, they have a regulation that falling parts with a weight of more than 5 kilos are not allowed. In Sweden, we allow up to approximately 1 kilo, and no sharp objects that could cut you are allowed. So there are differences today, but it is mainly for people that are escaping from the fire and for the fire brigade that it should be possible to do the job safe way.
All right, that's clear. Another question says, have any test results be compared and or correlated to actual real-life fire experiences worldwide?
Yeah, if we look in the literature, there are lots of results made many years ago, and there are lots of studies that have been carried out during the years, and I think we can learn a lot by going into the literature and see what has been done. I know in Sweden, for example, it was made a lot of not real fires, but at least fires, room fires, real room fires, different sizes of room fires, and how it worked with different opening factors and so on. So there are lots of results in the literature, but it is always difficult to compare with what we say real fires, but controlled real fires, yes, there are lots of results available.
Okay. There's a question here related to the smoke generation, whether it says in the US, we do not regulate smoke generation of the roofing materials. Do you think it is necessary?
I'm not sure, but I just a couple of weeks ago I heard a presentation about the Grenfell Tower fire, and there was a lot of casualties caused by smoke, even though it was a facade fire. So in some way the smoke have got into the building and killed people. So it might be that we have a problem with the smoke. Otherwise, my first thought when people were talking about smoke and facade, I said, what the heck, it doesn't matter. It is burning outside. The smoke will never go indoors. But it might do. And if it does, then the smoke could be a problem. But I can see it is also a very difficult scenario to take care of in a test, because we have to distinguish between the smoke that comes from the fire source and the smoke that comes from the test object. And we also have to look on how tight are the detailing in order to prevent smoke from going into the building again. So it's a very complex problem. So I think it will take many years before we have solved that, if we're going to take smoke into consideration with respect to facades.
All right. Okay, just regarding the Grenfell fire, there's a question here that says, how did Grenfell happen if England had a reasonable test method?
That is a very good question. I'm not an expert in this. I can only refer to what I have heard from other scientists. And what I have heard is that the Grenfell Tower, it fulfilled the requirements in the UK. But anyway, it became this huge fire. It was not a big fire in the room where it started. It was quite a small fire, and the fire got through the facade system through some penetration or some gaskets or something at the windows. So it was a very small fire that started all this. And then, of course, the system was not suitable to have on facades. We can see that now after the incident. So probably it was a mix of the test methods that had been used was not good enough to show that the materials were safe. That was these ACM products. But I think there were a lot of things that went wrong in this dramatic fire. Okay. But I have not read the police reports, so I'm not the right guy to ask these questions.
All right. Okay. All right. There are many questions, and we have not so much time. Next question says, could you confirm that choosing the alternative method would have negligible effect on the duration of the round robin second phase of the European project?
I think we have a tricky project in front of us because we're supposed to make a round robin at the end and show that the produced method is robust enough to harmonize, and that is that it has enough repeatability and reproducibility. I'm not sure that this alternative method will be good enough, but I hope that we have a possibility to get closer to a good method with this alternative method. But there is some research that must be done before we can start the round robin. We have to look on the effect of the environment, ventilation conditions. We have to ensure that we have good enough tolerances on the fuel source and so on. And we also have a difficult task, and that is to choose how are we going to perform the round robin. How can we perform round robins that shows what we want to see? And that is, we can't do it on a non-combustible facade, because that won't give any answer. Okay, it can show that perhaps the heat exposure is the same from time to time, but we can't see if it classifies the products in a correct way. So we have to choose some systems to do the round robin that we believe can give the correct answers. So it's a tricky. It will be a very tricky project.
Okay. All right. Now here I have a question related to the test made by FM. It says FM Global recently developed a parallel panel test, FM 4880, which used two 4.9 meters panel placed 0.5 meters apart. Has the European Commission reviewed this test as part of their review?
No.
Well, PS and SPA, getting more super conservative.
Yeah. No, we have only looked on the methods used in Europe so far. But of course, in other studies, we have also looked on other methods, and when we did this work, it was quite clear from the Commission that we should use the two methods that they provided, the British and the German method. They should be the basis, no question about it. It was not allowed to go too far from these methods. So, and then when we looked on the other European methods, it was mainly to get the picture on what to be assessed and how is it assessed in the different member states. So we have not gone outside Europe at all when we have made this project.
All right. Okay. Lars, there are many other questions for you. Unfortunately, we have no more time, but I will send you the question to you. So maybe if you can answer to the people or whatever, that'd be great. Because there are,
I will try.
Demonstrate it is a very interesting topic for all fire engineers. So thank you very much, Lars. Let me, before finishing, let me introduce Luis Gerossi. He's manager of the professional development. He's going to tell us about the next educational programs. Luis?
Hey, Jose, thank you. And thank you, Lars, for a great presentation. Just before we end today's webinar, I just wanted to take a moment and note some of our upcoming events for SFP. We do have our annual conference, our 2019 annual conference and expo being held in Phoenix, Arizona, October 13th to the 15th. We have over 55 speakers presenting on technical topics such as exposed mass timber and high-rise, energy storage systems, and the wildland-urban interface. We have keynote speakers on the changing landscape of engineering demographics from Karen Horting, Executive Director of Society of Women Engineering, and Raquel Temez, the Executive Director for Society of Hispanic Professional Engineers. We also have a keynote presentation on the current state of technology in the 21st century construction projects by Jeffrey Yoders from Engineering News Record, as well as plenty of networking events for you to engage with fellow leaders in the fire protection engineering industry. Registration is available on our website, sfp.org. And then please look again to our website for our upcoming webinars. Our next webinar is next Wednesday, which is on the topic of advanced detection technologies presented by FIKE. And then, of course, our continuing series focused on global perspective, specifically in Europe, throughout the rest of the year. More information on our website under events and education, webinars, and conference. So again, just a little plug for upcoming opportunities, and I'll give it back to you, Jose.
All right. Well, thank you very much for the information, Luis. Well, it's only I'd like to thank to everyone who has participated in today's webinar. And of course, Lars, thank you very much for an outstanding presentation.
Thank you.
See you next time. Bye-bye.